Hello, digital e-festers. I'm sorry that we didn't get the opportunity to meet face to face this year, but I'm excited to have the opportunity to show you the revolutionary proprietary CAD technology from Siemens Digital Industry Software. It's called Solid Edge. And after seeing the introduction, I think you're going to agree with me that it's unlike anything else you've ever seen and possibly even used. Solid Edge uses a technology we call synchronous technology to remove the pitfalls and frustrations of traditional history-based CAD modeling. With Solid Edge, you no longer need to worry if you model the part correctly, so that when you make an edit, the downstream features won't fall apart and require tons of rework. Also, with synchronous technology, design intent can be changed on the fly. So let's take a quick look at Solid Edge. The first thing I think is important to understand is what is design intent. So let's open up just a very simple little block. And this was modeled with just 4 features. This is an ordered model, similar to all of our competitors, where it's feature on top of feature on top of feature. So in this part, you can see how it was modeled. Let me turn off the dimensions here, and I'm going to do a go to. So I'm going to roll the model back to the very first feature. So there was a shape and it was extruded. The next thing that happened is there was a cutout added, and then a second cutout, and then the rounds were added. So at the time that this was created, what was important were the 2 cutouts relative to the rest of the part. So those were put in as features. But the problem is design intent can change. What if this part needs to be modified? What if this 75 dimension needs to change to 100? But the angle and the 35 need to be maintained. So really it just needs to add 25 millimeters of material off the back side of the part. What if this center piece needs to be taller or shorter by, say, 20 millimeters? What if this center piece needs to be 40 millimeters instead of 30? Well, the only way to do that in a history-based CAD tool is to go and take 5 from each of the cutouts to end up with a width of 40 in the middle, based on how it was modeled in ordered modeling. So let's go ahead and take a quick look at how we would change this model in a history-based CAD tool. So the first thing I need to do is roll back to the very first protrusion and go to its profile, and I want to make this 100. So if I just go ahead and change that to 100, notice that that 35 now changed to 60, and we said that that needed to be maintained. Also, that angle changed, so we don't want that. So let's undo, and we need to figure out why that's happening. Well, I see that I have a locked dimension of 40 here. Well, if this is going to add 25 here, it's also got to add 25 to this 40. So we need to unlock this dimension so it's free to move. Now we're ready. Let's go ahead and change that again. Still the same result. Why is that? Well, when this was modeled as a rectangle. It was centered on the coordinate system, and it created this relationship from the midpoint to the coordinate system. That's what's keeping that there and moving the other side. So that has to be removed. Now this is all design intent that was added, but not necessarily on purpose. It was just the way it was modeled. Now that's restricting us from making the edit that we want to make. So now we can go in, change that to 100, and now we got the result that we wanted. So we'll go ahead and accept that, let it recalculate the rest of the features. What happened here? Well, we have a cutout. Well, why does it not go all the way through? Well, because when this was modeled, whoever modeled this, for the extent step, they just clicked a point, which created a finite extent. And once the model got longer than that finite extent, it no longer cuts all the way through. So really the design intent should have been to go through both sides of the material forever using the through all instead of just clicking a point. That way it wouldn't matter if that got longer. So that was just an error in modeling at that point. Alright, so now let's move on. So we said that we wanted this centerpiece to be 40 millimeters wide. Well, the only way to fix that then is to change the cutouts. So we need to go to the first cutout and let's edit its profile. And remember I said I need to take 5 off of that, but this is modeled from the center. So really I need to add 5 to that dimension and then subtract 5 from that dimension to keep the cutout, or to keep this leg the same width on the other side. So let's go ahead and accept that. And then we have to go edit the second cutout. This one was dimensioned differently. It's dimensioned from this edge. So we know that we want that to be 40. And again, we'll need to take 5 off of the cut to maintain the width of the other leg here. Alright, so that should do it. Okay, perfect. Alright, so we just had to do some calculating and figuring to get that to be the correct dimension. Now, we said that we want this centerpiece to be 20 millimeters taller. Well, that's a problem because it was modeled as a protrusion. So we're going to have to go and create maybe an extrude, and we'll go parallel off of this top face. We'll come up 20 millimeters, and basically then what we're going to have to do is just include or project these edges onto that plane, and then we need to trim those together. Alright, so that gives me a rectangle then that I can extrude down to the top of the other part. And we still need rounds. Alright, so we had to do some modeling there to get that the way that we wanted it. Now, what if you came back and told me, well, that needs to be 20 millimeters shorter, not taller? Now I'm going to have to go and create a cutout, cut the top of that off, re-round it, and so it's just a lot of work. And so that's just some of the demonstration of what design intent is. So let's look at how we could do this in Solid Edge using synchronous technology. So let's go ahead and close the model. I'm going to reopen the exact same model, and I'm going to move this to a proprietary tool that we have in Solid Edge called Synchronous. So I can just right click and I can take any model and move it to Synchronous. Okay, now that it's in synchronous mode, that means I can make whatever change I want wherever I want because I'm always changing the model. I'm not looking at how the model was built. I don't care what these features are. What do you want to change? Well, this dimension needs to change, and so I'm going to change that. You notice the blue face, that's the face that's going to move when I make a modification. So I'm going to key in 100, and it just does it. It doesn't care how the model was built. We also said that this needs to be 40. Well, I can just simply select that dimension. The arrow's pointing in both directions. So as I make a modification, you can see it's getting wider. It's making the cutout smaller. So we'll make that 40. Very simple, very easy. I don't care how the model was built. This needs to be taller. So as I click this arrow, I can pull this up. I can make it 20 millimeters taller. I can make it 20 millimeters shorter. Doesn't matter. Again, makes no difference how the model was built. So synchronous technology makes it completely flexible. Change whatever you want to change with your design intent. Maybe you want to maintain this 30, so I'm going to go ahead and lock that down. And now what happens when I change this and I want to make it wider, it's going to maintain that to always be 30. So as I'm changing this, also notice that it's changing the other side. We have this proprietary tool in Solid Edge called the Design Intent Manager. So when I click on a dimension, these are the geometric conditions within the part that it's going to try and maintain. One of those is symmetry. So it's seeing symmetry about the coordinate system, about the center of the part, and it's maintaining it for me automatically. So as I make a modification, it's keeping the part symmetric. Very, very powerful functionality. This next example is something I know you've all encountered before if you've ever used a history-based CAD tool. This model is a fuel tank from a lawn mowing machine, and you can see this is an ordered model also, so it's a history-based model. So there are a lot of features. And so the design change that is required is that this angle on the front be rotated out 15 degrees from this bottom corner. So the first issue I have is that I didn't model this part. So how do I know which feature needs to be edited? Well, you have to kind of guess. You got to touch the face and see what features are relative to that face. So I see that the first one that pops up here is this protrusion 10. So I'll go ahead and I'll edit that feature, and I see that is not the feature that is controlling that angle. So I'm just going to click escape. So I need to figure out which one it is. It's not the draft. Protrusion 1, looks like that's the shape. So how scary is it to roll the model back to the very first feature in the tree? So you see all these arrows, meaning it's rolling the model back to the profile of the very first feature. And we want to, we said we wanted to add 15 to that. Okay, and then once you add 15 degrees to that, you let it recalculate all of the downstream features. And how many of you have seen this issue? All of a sudden you have a lot of broken features. There were dependencies between the features, like we showed in the very first design intent block, where you had a dependency based on where things were and what it expected. And now I've got to spend hours and hours trying to figure out what I need to fix, what I need to change to get that model back in shape. And you know what? A lot of times it's just easier to start over because it becomes such a cobweb, such a mess of features. So let's close this file and let's see how we would do this with synchronous technology. So open up the same model again. This time I'm going to take the last feature, move it to synchronous, which means it takes the feature that I selected and everything above it, moves it to synchronous, so now nothing is unordered. Synchronous means that there is no dependency. I can take protrusion 1, I can put it anywhere in this feature list, and it does not affect the model because it's not a recipe, it's not a history. The correct answer is the solid model. We don't care what features you use to get there. So how do you make an edit then if you're not editing a feature? Well, you edit the faces directly. What do you want to change? I want to rotate this face. We have this tool called the steering wheel. I'm going to put it right down here on the radius of the arc at the bottom. And then I click on the torus to initiate a rotation. And I want to rotate that face out 15 degrees. I don't have to worry about any of the rest of the model falling apart and breaking because I'm not editing features, I'm editing faces. What do you want to change? Does this face need to be deeper? Go ahead and push it deeper. Notice that those two faces were coplanar and it maintains it automatically. If you don't want that, it's just a matter of unchecking it. Now it's only going to move the face that I selected. Okay. You got two faces that need to be on the same plane. I want this face to be on the same plane as this face. I don't want to have to edit a feature to do that. We have some relate tools, and we actually have animated tooltips that show exactly what that command does. It takes one face and makes it coplanar to another face. So I'm going to take this face, accept it, and I want that face to be coplanar with this face. Just automatically does it, rerounds the part. Very, very powerful functionality with Solid Edge. Makes editing a breeze. Never having to worry about downstream features falling apart. So now that we've seen how we've taken some models that existed that were ordered, let's see how we actually model using synchronous technology. So I'm going to close this file and let's just start a new part file. I'm going to do an asymmetric part template and we're just going to model something from scratch. I'm going to turn on my base reference planes. So you can think of these as pieces of paper to begin modeling. So you need to determine, are you sketching a front view or top view, right side view of the part that you want to model. So let's just say that we're going to be modeling on the front view. And I'm going to start with just a simple rectangle. So I'm going to use my rectangle by center command. I need to tell Solid Edge which piece of paper or which reference plane I'm drawing on. So when I highlight it, it shows an F3 lock, so I can click the F3 button or click on the icon. I'll know I'm locked onto that plane because it shows me an F3 in the upper right corner and highlights the plane. You can use the view cube to bring that normal to the screen, and let's just click on the point and begin creating a rectangle. I'm going to key in exact value, so I'm going to go 250 by 50, and it adds those dimensions for me automatically. Go ahead and turn off our reference plane now. Actually, let's go ahead and add a few more lines to make it a little bit more interesting. So I'm just going to continue, and you don't have to model normal to the screen, you can model at an angle so you can see what you're doing. Let's add one more line down here. Alright, so how synchronous technology works when you're modeling is you select one of these regions created by the profiles. So even though the lines overlap, it doesn't matter because it creates a region. So you can click on the region, don't even need to click a command. Simply click an arrow and you're immediately extruding it into a solid. Just tapping the shift key toggles between symmetry and not. Depending on which one I select, which I'm creating. If I want to revolve this, make it a round part, I just drag it to an edge, click on the torus to initiate a rotation, and now I'm making a round part. Now obviously depending on which edge you put it on, you can get completely different answers. Maybe you want it to have a hole in the middle. So we can move it down here, initiate our rotation, and you can see that we've drawn a profile that we're revolving around a center line. Alright, so let's just go back to the basics. Let's go back to the rectangle, and let's just extrude this rectangle. And what I want you to watch are the dimensions. So when I commit to a width, you're going to see those dimensions migrate from the sketch directly onto the solid. Because in Solid Edge, as I mentioned in Synchronous, you're never going back to that protrusion to make an edit. You select on the model exactly what you want to change. If I click that dimension, I can change that dimension right away, 400. The other way to do it is by actually selecting a face. So I can select a face and drag it. Notice again, it's seeing that a part is symmetric, it maintains it. If we don't want that, we just disable it, and it's only going to change the side that I selected. Let's go and draw another line. I'm going to draw a line on the top, so I'm going to lock onto that plane. I'm just going to draw a line across the top of the part, and that breaks that into regions. So I can click that region. If I push it into the part, it's going to cut it away. If I pull it up, it's going to add material. Very, very simple. Now if you just think about this for a minute, the way I modeled that is I extruded sideways and then I extruded straight up. So what I didn't think about is the possibility of wanting to have that vertical leg at some angle. So in a history-based model, I didn't model it correctly because I should have modeled it as an L shape where I could change the sketch profile angle to extrude it. Again, in Solid Edge, we don't care how you model it. What do you want to change? As a matter of fact, here is the original sketch. It does not match the model because we don't use the sketch. As a matter of fact, you can delete that sketch. If you try that in a history-based CAD tool, your model just went away because it relies on that sketch. So again, how do we change it? Solid Edge, select what you want to change, take our steering wheel, move it to this bottom corner, that's where I want to pivot. I'll click the torus to initiate a rotation, and now as I move that, you can see that I can rotate that however I want to, and in this case I'm going to rotate it back 30 degrees. You want to add an angle to the side, no problem. Let's go ahead and reset our design intent so we have our symmetry on, and I'm going to put this right up here on this edge, and as I rotate that to add angle, notice it angles both sides again because it's keeping the part symmetric. Finally, let's take a look at importing a part from another CAD system into Solid Edge and what we can do to manipulate it using synchronous technology. So here I have the start of a robot claw mechanism. You may have seen something similar to this, and so what I've done is I've downloaded a step file from a website like GrabCAD, and I've downloaded that, and now I'm going to import that into Solid Edge and make some adjustments to make it fit our assembly. So let me go open up the step file. It's called the flat clamp jaw, and we're going to open that into a metric part template. And so there's the imported part. It's kind of hard to see, so let's go ahead and change the color. Make it a little easier to see. We'll make it a yellow. That's a lot easier to see. And so I know that the arms, those red arms, have to fit inside of this slot. So the first thing I want to do is see what the width of this slot is, and it appears to be 14 millimeters. So let's go back over to the clamp mechanism, and let's look at what the height of this, and we can do that with the inspect tool, and we'll just measure this line, which is the height of that arm. It looks to be 9.5 millimeters. And we have 14 millimeter gap, so we need to drop that down to about 10. So remember that with synchronous technology, I don't need access to the features. I can change the model directly wherever I want to. I've added this dimension, and if I click on that dimension and I start scrolling that dimension, you're going to see that it is seeing the symmetric face on the other side. It's also pulling the offset face that's down in that slot at the same time. And so I actually want to keep the width of the ears, the original width of the ears. So what I'm going to do is I'm going to add another smart dimension real quick here for that height, and what I'm going to do is lock that dimension, meaning that dimension can't change unless I actually physically edit it. So now if I pick this dimension and I start changing it, it's actually going to maintain that width and actually change the overall height. And so let's go with 10 millimeters to make sure that it fits over our 9.5 millimeter arms. The jaw that I'm going to be using is going to be picking up a fairly large box, relatively large box. So this jaw is a little bit too short, so I want it to be longer. Well, with synchronous technology, I simply select the face I want to change, click the arrow, and start to drag. Now notice that it's extending down to a sharp point, which is not what I want to do. I actually want to maintain the size of that face, so we have an option in Solid Edge to tip, meaning it's going to tip the angled face, do whatever it needs to do to maintain the size of that face that I selected as I drag that out. And let's go another 30 millimeters. Now I know what you're thinking, what about these teeth? They now need to extend down the full length of that jaw, but we don't have a pattern. This is an imported part with no features. Fortunately, with Solid Edge, we have a proprietary tool called Recognize Patterns. I simply select the face that I want it to recognize a pattern of, and it comes back and says, yes, I found a linear pattern. That's great. Now that we have a pattern feature in Solid Edge, I have something I can edit. So I can change the height. I'm going to go, or the length of the pattern. Let's go with 79. Going to add in 30 millimeters. And then I also want to change the count. Maybe I want 16 of those teeth. So we went from a part that was imported that had no intelligence based in it whatsoever to be able to change whatever we want to based on on the faces that we select. So pretty powerful. Alright, so let's go ahead and save this now. I'm just going to save with the same name as the step file was. So we'll go to the parts library. We'll go ahead and rotate the jaw into a position that's close to the orientation that we need, and we'll bring that in and place it in the assembly. To place it in the assembly, I'm going to go ahead and mate the bottom face to the bottom of the arm, and then we're going to align the end holes. And so now if I use the drag component, you can see that I can simulate that thing opening and closing. Now clearly we need a jaw on the other side, and it takes the same relationship, so we can capture those relationships using a command called capture fit, where we can save the mate and the two alignments. What that does for us then is when we go back to the library and we bring in another jaw, you can see that it automatically has the face highlighted that we want to mate, put on the top. The first hole we want to align to this end, and then the second hole we want to align to this side. Now if I use the drag component command again, you can see I can move that side as well. Notice there's no gear relationship between the two gears. We need to add that. So before I add the gear relationship, what I'm going to do is I'm going to rotate this gear in a position where it's in a fully open position, but yet the gears appear to mesh. Now we're not actually going to make physically meshing gears. We're going to use a relationship to do that, but we want it to look good, so we're just going to get it close. That looks about right. And so let me hide this top plate. And I'm going to use the assemble command to create a gear relationship. You can see all the different types of relationships we can create. We're creating a gear relationship between this gear and this gear. And we're using those cylinders to highlight their center points, or their center lines. And you can see right now the arrows are pointing in the same direction. Gears, they have to go in opposite direction. So we're going to use the flip button to make it go in the opposite direction. We also know the ratio is 1 to 1 because it's the same number of teeth on each gear because it's the same gear. Now that we have an actual gear relationship and we use the drag component, now you're going to see that those gears appear to mesh using that gear relationship, and both jaws will move. Now as we keep pulling them closer together, what we find is that we have interference. Obviously the gears the jaws overlap. So to fix this, what we want to do is change the length of this arm. Now just to make it a little easier to see, I'm going to change the material color on this. We're going to change that to white. Let's go with white glass on just that part so you can see that arm that's in there. So what I want to do is change the length of the arm to move the clamp jaw further away. And I can do that by selecting the face. So right now I'm selecting parts. In Synchronous technology, we can modify that part at the assembly level using the face selection. So at the assembly level, without having to go into the part, I can select the face of the part. This arc, or this radius on the outside, is concentric to the hole, so my Design Intent Manager is going to pick that up for me automatically, and all I have to do is start to change the length of that arm by dragging it out, making it longer, and as I make it longer, it pushes those jaws further apart. It looks like about 3.9 millimeters will push those jaws far enough apart that they don't interfere with each other, but are very close. And so you can see how powerful Synchronous is in the assembly level to be able to modify parts at the part level without having to jump in and out of parts. So by now I hope you've seen the power of Synchronous technology and what differentiates Solid Edge from all other CAD systems that are on the market. So the other exciting thing is Solid Edge is 100% free for students and educators. So if you're going to be using Solid Edge for academic use, just follow the link below to Solid Edge to go download it, and then also there are links to self-paced learning so that you can learn Solid Edge today. With that, I hope you enjoy the rest of eFest, and we'll hope to see you next year.